Hi, and welcome to the second episode of my YouTube series on AWS Serverless Stack, where we'll build an end-to-end application using AWS CDK and AWS Amplify. In the last episode, we built a stack to deploy our frontend with AWS Amplify and AWS CDK. We also created a storage stack, deploying two DynamoDB tables and an S3 bucket. And finally, we deployed a Cognito stack with the hosted UI so that you can log in with Google or Facebook, or you can use a username and password. And in this episode, we will expand on that. Before we get started, I noticed that very few people are subscribed. So if you do enjoy the content, consider to like and subscribe. It would really help me out. And let's go on to the agenda. So the agenda for this video will be to reach the goal to enable authentication and GraphQL operations on our Amplify hosted website. So we will make a slight adjustment in the Cognito stack that we created in the last episode. This has to do with adjusting the attributes. So this will enable the users to change their attributes in the Cognito directory. Think of name or address or anything like that. We'll also add some custom attributes. Then we will create a GraphQL API stack, which will enable us to use GraphQL operations with our Amplify stack and use a Lambda through the API to, do a query and get something back. And once we have the GraphQL API stack, we will integrate both the Cognito that we created last time and the GraphQL that we will create in this episode with our Amplify stack. And just to iterate where we left off. So the last time we created this hosted UI, and this hosted UI is on a separate domain than the website that we are actually hosting with Amplify. And the UI does allow us to log in with Google or Facebook and username password, allows us to use forgotten password or sign up. And if you do log in, you get redirected to the website. But in this episode, let's go to what we'll be creating. So in this episode, we will be adding the React Cognito UI that is provided by AWS to our website. So it's nothing that we will be creating. I won't go over any CSS and HTML mostly. So this is out of the box, and with this, we will be able to log in on our website again using Facebook, Google, or username password. You can also create an account, and after we are logged in, we will retrieve some attributes from the user. Well, the current user is Faruk, and we get some details, and we'll also change these. So you'll be able to, for example, change your name, cancelled for now, but you could add the company name, your VAT number. These are custom attributes, and you have some default attributes. Think of the given name, family name, you have a street name, and you have an address. And for now, the orders are mostly, these are proxy orders. And later we will also add the GraphQL API query that will retrieve the orders. In this particular episode, I will do another query, but the principle is the same, and that will all be working at the end of this episode. So let's get started with the adjustments on the Cognito stack so that our users are actually able to change their attributes. So I opened up my Cognito stack, and then we navigate to our user pool client. And in our user pool client, we will be adding an extra scope. So in the user pool client, we go to scopes, and these are the scopes that we need to retrieve the information, for example, from Facebook or Google, so that we are authorized. But besides that, we can also add Cognito OAuth scope and then Cognito admin. And this will give the user the scope to update, as you see it now in the screen. It will allow us the operations of update user attributes and also verify user attributes. So this is in case that you will change the email or the phone number, which I won't be covering in this episode, but later on in the series we will create a custom login form as well. So in that case we will also be covering that. For now I will be just adding this scope. That's all we need to do, and then you can deploy this stack again. After it's been redeployed, you should be able to see that scope also in the console. And once we have that done, we can actually continue. So that's all we will be changing in this stack. After it's redeployed, it should be available to use. And then let's go on to the next stack, which will be the GraphQL API stack. So I created a new CDK stack using CDK init language TypeScript. And from there, let's start populating this stack with everything we need to get the GraphQL API stack. So first thing I will do is create 2 new files with config.ts, and I will also add another one, types.ts. And if you've seen my stack, if you've seen my videos before, I like to copy and paste stuff. It saves me a lot of time. But let's go through the stack props of this stack just to get an idea of what we will be using. So we are creating a new interface, AWS Appsync stack props, which will extend the normal CDK stack props. And in there we will add a user pool ARN. So this is the Cognito user pool we created earlier. And then we will have an API name for the GraphQL API. We will have a customer table name. So this is in the storage stack that we created in the first episode. It's a DynamoDB table, or in this case, DynamoDB table name. We will also have a customer table key. This is a KMS key. This was also created in the last episode. And we have a schema pet. This will be the pet to our GraphQL schema. So we will be defining a schema, which will then have all the operations and stuff like that. But we'll get there in a bit. Then the domain name. So I currently don't have the domain name. I don't use it, but you could use a domain name to add a custom domain name to your API. I was considering adding it, but I ended not doing it. But if you do want to add it, I just forgot to remove it here. So I will also be adding a Stripe secret key. So this is just the secret key for my Stripe API. If you're not using Stripe, then of course don't add it. And I also have some prices for things. So this is just my project. If you're using different stuff, you don't need to add this. But I will be adding these with the customer table as environment variables for my lambdas. So my lambdas can access these values, and I will be using them also in the lambda. And we will get there, and I will show you when we get there. So in the config, what we are doing is actually just filling in the stack props. So the types define all the property types that we are expecting, and then here we will add the values of the actual stack. So in here, I left the user pool and all that open, so you can just add in the user pool ARN. So do mind that it's an ARN. The API name, you can just think of an API name yourself. The table name, this has to be the customer table name, as this will be retrieving orders or deleting a customer. But we won't be fully going into that in this episode yet. So if you don't do this, it's also not the worst thing. What is important is the location of our GraphQL schema. So as you see that I should be creating a directory called GraphQL, and in there I will create a schema called schema.graphql. This file will be containing all our types for the queries and mutations that GraphQL allows us. It will also allow us to add identifiers for authorization, so that you need to be logged in with Cognito, for example, to make a request. So now that we have our stack props and we have these as well, I also want to add this in the bin. So that should do for this part, and just so that I don't need to type this, I will copy it, and we will start populating the lib. So I imported the stack props type so that we know what to expect in the props, and from here let's just start building our API. And what I will do this time, I will add a new folder and I will call it services. And then here I will add another folder and I call it lambda, and I will add another folder and I will call it Appsync. And in these folders I will just add the services that we'll be using and then import them in the main lib file. And I just do this to keep it nice and tight. You could also put it in, but we get a really long file, and just to keep the files a bit shorter, I just decided that I will use it like this. So I will create another one with solver.ts. So we'll expect that this one will export the Appsync API, and in the resolver it will just return a lambda with some we will creating multiple lambdas, so it will create multiple lambdas. So let's first start with the API stack, and then we will go to the lambda itself. So I just copied and pasted some code to create a GraphQL API, and let's go through what we are actually doing. So first I'm importing some services from AWS. First of all, CDK from the CDK lib library. This contains the CDK stack that we are expecting here as our first input. Then we will also add Appsync and Cognito, and finally also logs. And logs, I'm adding this just to have log retention. By default, all AWS Cloud logs don't have any retention date on them, so they will be kept indefinitely. And by using logs, we can add, for example, in this case, we are adding retention days 1 month. So all the logs will be retained for 1 month, and after 1 month, they will be deleted. So we're also expecting another lambda that we are actually not creating to be present, which will be doing this. So if you do see lambda in your account, it probably has some name as log retention. You know where it comes from. It's because you are using log retention. So then let's go and see what we need to create a GraphQL API. So we did import Appsync, and from Appsync we're gonna create a new Appsync GraphQL API. And here I'm using stack, but if you're using the main file, it would be this. I'll demonstrate that as well in a minute. We have a construct name, and then we have the name of the API. So in my case, I would probably call it like print helix API, but you can call it whatever you want. Then we are referencing the props as we had the location to the schema. So that will be this schema, and we are feeding the schema to the construct, so it will know all the types and whatnot. Then another part is the authorization part, and you might notice that the default authorization I am using is Cognito user pools. And what this means is that by default, when we are doing a request, it will expect that we are adding a Cognito identity, authorized identity or user to the request. And we have to, of course, link the user pool that we created in the last episode. So I had I will import that in a bit, and we will add that here in the user pool config object, user pool, and so this will be the user pool that we added, and we will import it with the user pool ARN. So we had that in the stack props. Here we will import it with the ARN and then pass it on to the API function so we can link it to the GraphQL API. Then additionally to that, I will also implement IAM mode. So next to being authenticated with the user pool, I will also allow users to authenticate with IAM. And in this video we won't be going through that, but in a later video we will also allow unauthenticated users to assume an IAM role, and with that IAM role they can then call this API. Finally is the log config, and I already explained a little about this, but field log level just will show you which level of logs you will receive. So for log you can say none, you can do error, or you can do all. I just want to have all for now. And the log retention I also mentioned already, we will be storing the logs for 1 month, and after 1 month we will be deleting them. So this will, with the correct input, return a GraphQL API. Now that we have that, let's fill in the resolver. Also for the resolver, just paste it in. And again, we have the imports here, so I won't go to this CDK and the logs as we just mentioned them, but I'm also importing Lambda and Node.js. And the reason that why I'm importing Node.js is that sometimes I also use packages, and if you're using npm node modules, they are not getting imported into your Lambda by default if you're using just the Lambda function. But if you're using Node.js functions, then it actually bundles your dependencies into the Lambda as well. So that's why I tend to use the Node.js version, as I'm also using Node.js for my functions. Then we have some props. So we're expecting a name, an entry. So the name is just a string, entry is also a string. It will refer to the location of the file that has the handler's code. And finally we have some environment keys and values, and these will be added to the Lambda environment variables so that they can be accessed from the Lambda. And we've created the Lambda before, but just to walk through it quickly, it's a new Node.js function. It will have a stack, so this will be this if it's in the main stack, and we will be passing the stack just here. And then for the construct name, I'm actually passing the name again. And the reason why I'm doing this is because we'll create multiple lambdas, and you can't have multiple lambdas with the same construct name. So that's why we are passing the name as the construct name to avoid errors. Then we have the function name itself, so again the same value, and the rest pretty much speaks for itself. So the handler location, we are adding some extra memory to make it just a little bit faster at the start. Then we're choosing the runtime. The timeout is set on 30 seconds. And in this case, we will keep the logs for 2 weeks. And as I mentioned before, the Node.js function allows you to bundle. And I am also minifying and bundling. And finally passing in the environment variables. So this will be an object with some keys and string values, and the Lambda will be able to access them when running. So I will save this as well. So we have the API and the resolver. Let's go back to our main file. And in our main file, as I mentioned, we're gonna import a couple things. So first, let me import all the required services. So we will be using DynamoDB, KMS, we'll be using Cognito, Appsync. We also have the API, of course, that we created here, and the resolver, which will create a Lambda function for us. So first the imports. we will be importing from DynamoDB a table from table name, and the table name we are getting from the props. So fill your table name in here, and I created like an order customer, I think PH customer table, but just look into your console, what's the name of your table, and just add it here. Then we're also getting the KMS key that we encrypt our data with, because if it's not decryptable, then we cannot read this data. We are also importing the user pool, as I mentioned earlier, and for that we just use the user pool ARN. You can also find that in the console. If you don't know where to find it, just go to your user pool. Next, if we have the import, we are able to create the API. And I hate it when the outline is not correct, but now we are importing the API that we created just now. We're passing in this as the stack. We're adding a name from the props. We're adding the schema path, which will point to this location. And we're also adding the user pool that we created in the last episode. And this will allow that the user pool users are authenticated to make calls to this API. Once we have that, we need to create some lambdas, and in my case I will create 3 different lambdas, and each of these lambdas will do something else. So first of all, I will have a payment resolver, and in my case the payment resolver will handle the Stripe payment intender. So if you're also using Stripe, then you can watch along, but you can also of course just create one of your own functions. But let's go through the functions that I'm creating. So I'm creating a payment intender, I'm creating a customer create order resolver, and I'm also creating a delete account resolver. And I think I have a mistake here. So I will do something like get order resolver. So 3 functions. Idea is that one will get the orders from the customer order table for the logged in user. One will delete the user. So you can also do this just in Cognito, but because we're also storing some data in the table, we also want to remove the DynamoDB table item. So that's why we're creating API point to trigger a lambda that will delete everything except for, of course, the order data. And for the payment intender, just like I said, we will expect that the frontend will send an object, and this object will, in my case, contain an order, and this order will be validated on the price, and it will send the payment intender so that you can pay with Stripe. And you might have noticed I'm adding the environment variables here. They also come from the stack props. And I'm also adding this line, which you might see, which just enables you to reuse connection if you get re-triggered within some certain time span. You won't create a new connection for whatever you are using. In my case, I'm creating a client to use the, for example, DynamoDB client or the S3 or whatever. So that's what that stands for. But you can also add any other value that you like. But do note that environment variables need to be strings. So when you're adding them, just pay attention to that. So we have our API in now, and we have 3 resolvers. Then we need to, of course, also add some permissions. And for those permissions, we have to do a couple things. So we're to the customer tables, we are doing grant read data on the customer resolver. We are doing read write data on the delete resolver, as it will also need to delete something from the table. Then we also need to add the permissions, of course, to the KMS key. So we will grant encrypt decrypt to both the resolver and the deleter. And the next step which we will do is create data sources. And I decided to create 3 different lambdas, but do note that you can also create different kinds of data sources. For example, for the delete action, I could also maybe link it directly to DynamoDB as a data source, and then you don't have to have a lambda in between. But I don't know if I might add extra actions or I need to delete more stuff. So for now I just created 3 lambdas, and these 3 lambdas will be triggered whenever one of those queries or mutations gets run. And as you can see, we are adding it to the API. So it's like API add lambda data source, then we give it a name, and we're adding the lambda resolver that we created there. And if we're using a different data source, so we can use DynamoDB, EventBridge, and whatnot. So they are all written here. If you're using TypeScript, you have the IntelliSense that will complete it for you. So there are some options there, but in this example we will be just using lambdas. So we have the data source, we have permissions, and final thing that we need to do is map these resolvers also to the queries that we want to do. So I'm adding for the payment intender data source, creating a resolver, and it will resolve a type of query with the field name payment intender. And then what it does is just the mapping to the lambda, and the result is also the lambda result. Well, it's pretty much the same for all 3. There's a minor distinction. These 2 are queries, which means that I'm querying for some data and expecting something in return. And the final one is a mutation, and so it will be a difference, but won't be going too deep into that. But just know that there is a difference. So now that we have that as well in our stack, we're pretty much done with the infrastructure. But before we deploy this, of course, you need to fill in the config. So fill it in according to what you have into your account, and then one of the final steps is actually creating the schema for our GraphQL. And as I mentioned, we have differentiation, well, you know what I mean, between queries and mutations. And so our schema will consist of either queries, mutations. You will also have subscriptions, which I won't be covering now, but it's another option that you can subscribe and listen to events, and unsubscribe, of course. But for now I will be using, in this example, a query mostly, and I will just show that you can also create some mutations. So in my queries I will have 2 queries. I will have the payment intender. As I said, I will expect an object which is an order, and it will return a string. And the string in my case is the secret for my Stripe account, just to create a payout form. And then I also have get customer orders, and the get customer orders will just get the orders for a user in the account. You don't need to have any input, and as each account is each API call will be signed with the Cognito user. As you can see here, only Cognito users will be able to call this endpoint. I would just get the sub, which is the user ID, out of the request. And in the payment intender, I intend to also let people use the site if they are not logged in. Sometimes this can be a threshold. So that's why I'm also adding the IAM decorator, which means that both AWS Cognito user pool users and AWS IAM users can call this endpoint, which is different for customer orders because you need to have an account to get your orders. And for mutations, I'm creating a delete account. And as I said before, because you are assigning it with the Cognito user, I'm expecting the username and the user ID, which I will be using, to be in the request, and then I will use that to delete the account. So those are the queries and mutations, and now we have to give the types that will consist of for these orders and customer orders. And this will be different for you in your project, so know that. I will quickly paste something in, and I will quickly say something about it that will maybe save you some hassle. So this is what I'll be using. Well, this is just a type, don't mind this. This is also just a type, but what I did want to mention is that so customer order is the object, is this object, and what would be different is that where I am expecting an order here, which is an input, and this is a type. So for customer order, I am using a type, and for the input, even though I have these types here, I am creating another input type to create the orders, which is an input. So this is something to note. If you're new to GraphQL and you might get stuck on this, so do note that there's like types and inputs. I myself was for once a bit stuck on this myself, so if you are, just a quick note. Then for this part, let's just go over it quickly. We have our schema, we have our resolver, we have our API. Now we actually also need the code that will do the resolver's work, of course. So for that, let's see. I already gave them, of course, a name. So here we are seeing that I'm expecting a folder called source, and then we have one payment intender and another folder customer orders and another one. Delete account. So I might not make all of the lambdas. Maybe I'll quickly show it, but not fully complete it. But just let's go over the first one, and you'll have an idea of how to do them all. So in the first lambda, this is the payment intender. In this lambda, what I'm gonna do is create, I'm gonna receive orders, and based on the orders, I'm gonna validate these orders, and then I'm gonna send back Stripe payment intender secret key, which will allow me to create a payment form. So that's what we're gonna create, and to do that, let's see, maybe I actually do need an extra folder called types. And the first thing that I'm going to do is actually create, the types for the event that we're expecting inside of the Lambda. And I immediately see that we need to install the AWS Lambda types. So npm e. So let's add type / AWS dash lambda. We'll install that. And from there, we are getting the Appsync identity Cognito and the Appsync identity IAM. And as I said before, currently we're not doing anything with the IAM, but later we will. So I'm just importing that for now. Then I will create a type. So in the payment intender, we are expecting a payment intender event. The payment intender event will have 3 fields. So it will have an identity, which will be either an Appsync Cognito identity or an IAM identity. We won't be doing anything with it currently, but know that it's there. Then it will have an info field with the field name, and it will have arguments with an object in it called order, and then it will have an object in it called products, and the products will be an array of products inside of the order. So that's what we'll expect in here. Then let me also, for my case, so what I'll be using as an order, as a product, will contain some fields. This is of course related to my website that I'm creating, but you can create any kind of product or fields that you want. But do note that this has to be the same as what you are doing inside of your GraphQL schema. So inside of the payment intender, I'm expecting the return value will be a string. So I do need to return a string inside of this function. And if I'm expecting a customer order, as we see here, which is an orders array with customer orders in it, then we do need to return that. But in our case, in this particular function, we will be returning a string. So let's see, do I need additional types? For now, I might not need them, but I'll just quickly add them here. So I'm adding the I delete account event, and as I said, I will be expecting an identity in there. And same goes for the customer orders event. I expect an identity to be in the request. You don't need to have additional fields or arguments. I will just get your identity, and based on the identity, you can just get the account details or whatever you are doing in that case. So those are the types. Now let's go on to the function itself. And in here, copy paste. I have to install Stripe. I have to also install the SDK client for DynamoDB. And I have a function to validate the price, but as it is not really relevant at this point, I will just do this. Okay, so this is what we are expecting normally. So input any. I'm just replacing this function just to quickly have that also work. But let's go through what we are actually doing. So I'm importing Stripe, and if you're not using Stripe, you don't need to import it. But as I'm using Stripe, I'm installing Stripe, then DynamoDB, and I also import the event that we just created. And what I'm doing here is called lazy loading. And what lazy loading does is I'm creating the clients outside of the function, so that if the function gets re-hit and the client is already existing, we won't recreate the client, we will just reuse the client. Then for the first environment variable we see here, we are getting the Stripe secret key from the environment variables of the Lambda. That's why we were entering that there. And as I said, lazy loading both clients. We are logging the event, and then normally I of course validate the product, the user, and the price, but for now I've removed those things, and we're just creating a payment intender. So if you're wondering how to create a payment intender in Stripe, we are awaiting Stripe payment intender create, then we're adding an amount, we're adding a currency, and this, by the way, not correct, as the amount is actually in cents, so 1000 would be 10 euro in this case. So do note that if you are using Stripe, that's in cents. And after we have a payment intender, in one of the next episodes, we will be looking into step functions. So after we get a payment intent, we're gonna trigger a step function which will keep track of this payment intent and see if the payment has been completed. If the payment has been completed, we will be adding it to the orders table, and if it's not completed, we will just remove all the, well, I will be removing all the pictures. So sometimes I might say stuff that's not relevant to you, but I am creating this specifically for that website as a demo. So if you don't need it, just don't use it. Then finally, as I said, we're expecting a string to be returned from this lambda. So what I will be doing is return a JSON string, and I could of course only return the client, but I will also be returning a status code. And if you don't want this all to be a string, then you would have to also add status code inside of the GraphQL query. So you would need an object here that also accounts for the status code in there. But let's go back to the function, and if this fails for any reason, I will just be returning null and with the status code 500. So this is the function that will be triggered when the GraphQL API has been created. And I will also show how the delete account will look like. And this is just really quick, so you probably need to do a bit more validation on the accounts and stuff, but just to show you how this would look like. And do note that this will only remove an item from DynamoDB, and there's a separate action that you need to do to remove the user from Cognito. So let's keep those separate. Quick run through. I'm importing the SDK again for DynamoDB client, and then I like to always import like the command, the input and the output as a type. It just gives you a little bit more help with the IntelliSense. So we're getting an event. It's a iDelete account event. Again, we are lazy loading the client. We are logging the event. Then from the event identity, we will get the sub. And I told this before, and we saw it in the previous video, but the sub is a unique identifier. So it's a string like a UUID, which identifies our user and is unique to that user. So if we do find the sub, we will delete item from the customer table. And as you see here, we need to add the table name. And here we are getting it from the environment variables. And in the environment variables, there is a customer table name. And from there, we will delete something with the key for account ID with a string value, which is the value of the sub. So this will look for the user with the account ID that's equal to this sub, and then delete that user. So if the user is deleted, we will return, in this case, this JSON. Probably, let me quickly have a look. So if there's a delete account, then we do need to return a string. As you can see here, maybe that's not the best idea, like this. This would be a little better. Okay, let me quickly fix that here as well. Okay, so in our GraphQL API, we're saying that we'll be returning a string, so we also really need to return a string. That's why I quickly fixed that. But as you see, it's very simple to do this. And if you're new to this, my tip would be just like I do, import these SDK commands, and you can use the IntelliSense to complete the commands for you. So maybe you're new to this. As you can see, if you just press Control space, you can just see each option that you can enter there. And sometimes I'm building something for the first time and I tend to use these types a lot just to see which values are there and how I can fill these values in. So that's something nice. Well, this is this function, and customer order would be pretty much the same, but I will give you a quick demo of how it can look. Next.js. This is just the basic example again. We're lazy loading the client, we're getting the get item command, input, output, and the command itself. Then again, the customer table is in the environment variables. We're getting the sub, and then for the projection expression, which is equal to which field do you want from the object, we are getting the orders object, and then again passing that through the front end. And in this case, we are expecting customer's order, which would be an array. So the return value is not correct currently, but I would have to change that. But I won't be deploying this currently, so I won't be changing that right now. But I will be deploying this function where I will send an order and I will validate the price and I will send the payment intender back just to see if everything is working. And we will of course integrate this into our front end. But depending on your needs, you should adjust your lambdas, and don't forget that they also need to be present here as data sources. Give the correct permissions, and once you've done that, you can actually deploy this stack. And once this stack has been deployed, we will integrate it with our front end. So for now, I will be deploying my own stack with all the code in it. I will upload this stack so you can have a look at how it looks in a basic example and adjust it to your needs. So for now, let's deploy it and then switch over to the console to see if it's there, and then integrate it with our Amplify. So after deploying our GraphQL API, we should be able to log into the console, and in the console you should be able to find the API that you defined. And to integrate this into our website is pretty simple. Well, first of all, you do actually need to have Amplify CLI, so you can run this code. If you already have Amplify set up, you don't need to run the Amplify init, but you do need to run the second command here, so the add code gem for the app ID, and then you also run the Amplify code gen. What this will do, it will create the GraphQL types and queries and mutations inside of your project. You will be able to reference them. And finally, there is a config here that you can download. And after downloading that config, you can just copy and paste that into the AWS config.js that we will create in a bit. And how do you get the AWS config.js file? Well, then we go to AWS Amplify into the console, and what we're gonna do is launch the studio. So to use the backend with Amplify, we'll be launching the Amplify studio. And once the Amplify studio has been, well, you first need to deploy a couple things, so it might take just a second. And once you have deployed your studio backend environment, you can actually just click the authentication settings and just select the Cognito user pool that you created with the user pool client, and then save it. Now you have your Cognito configured. Next, what we will be doing, you can, if you want, also do the same for storage. So go to storage, you will be able to select the S3 bucket that we created and add that as a storage. I will be doing that in a later video as well, where we will be adding pictures to the S3 bucket. So once you have configured the authentication, you can go to this local setup instructions button. And once you click it, it will give you a command. And that command shows you how to integrate Amplify into your project. So you copy this command here, go to your Next.js project, and then just execute that command. You do need to have Amplify installed, and after using it, it will ask you a couple questions. Once you're done configuring it, you can execute the commands that you got from the Appsync. So you can configure this one and download these configurations and add these configurations to the Appsync, to the AWS config.js. And so you download this and then you add it just to show it. And I want to mention this, if we look at the documentation of the AWS Amplify, then you can actually add the GraphQL API very simple with just adding this command, AWS add API. But what we are doing is creating GraphQL API with CDK and then integrating it into our stack. So this is not what we are doing. We are using existing AWS resources, and in that case you can see that when using an API key, that's not the case. Well, we're using this one. So this is what we're expected to have into our Amplify configuration, and we will get to that in a second. So now that you have run the commands from the local setup instructions, and you've also downloaded the config from the Appsync, we will move over to our front end and then configure all of that in our front end. So let's switch over there. So I switched over to the front end Next.js project that I have, and in there, if you just executed the commands for Amplify, you should now have a AWS config.js, AWS export.js file. And just for convenience sake, I created the AWS config.js here to show you that I have this file with all these settings, and then I just copy and paste a couple things here. So this is what you should have with a different link after downloading the GraphQL API settings, and this file of course should be there after you executed the local settings command. And I also have this one extra is for adding my S3 bucket. So this is what you should have as well, but maybe with different values, of course. But after you have these configuration settings, we still have to allow our app to use them, and we also need to install a couple things. So I will go to my package.json, and here I will, well, not all of these are of course necessary for you, but just to highlight which ones you need. You need the AWS Amplify /UI React. This is what we will use to create the login UI. And of course you also need AWS Amplify. And once you have those installed, you should be able to configure your Amplify settings. And you could do this at a couple locations. So you can do this in the layout. I noticed that if I do it in the layout, I have to use the use client to add the use client operator here, and then I cannot use the metadata. But I have to say I'm not the mega front ender. Mostly do backend. So if you know why this is happening, maybe add it in the comments. So just to fix that, I currently have a wrapper for the layout component. Let's go to the wrapper. Here. what are we doing here? I've created a wrapper for the layout component, so meaning that layout contains everything, and this should contain the layout. And in there I'm using a couple things. So from Amplify / UI React, we are getting the Amplify provider and the authenticator. I will wrap the entire thing in these two, and what the authenticator does is it allows us to use the use authenticator state that is also provided by the UI React library, and the Amplify provider just allows us to add our Amplify configuration. And I'm currently doing it like this. I've seen that you can all do it in a single one, but I don't know. I'm just setting all the configurations like this. And what you're seeing is that I'm inputting the config file that I have in the root of my project into the configuration, and Amplify is from AWS Amplify, as well as authentication, API, and storage. So the Amplify is just the Amplify settings. The auth is for the authentication with Google and Facebook and all those things. The API is for the GraphQL operations, and storage we will be touching in the next episode, but that's for S3. You might see that I'm also adding SSR2 for server-side rendering, and well, you just need to add the operator, you don't need to add much else there. And then after we have this, the application we are using should be able to access the settings that we have in this file that you got, so the AWS export.js. Do note that when you upload your configuration, this file will not be there. You can enable this in the settings for in the console, that it will generate it when you are building a project for that environment, or you can I don't know, store it in a S3 bucket and retrieve it in the pipeline. However you do it, you just note that you do need to have these configurations to make your Amplify stuff work. So, well, that was the next place that I wanted to go. So once we have configured the settings and we can actually access these, we're gonna go to the login page. So the login page I showed you before. Maybe I can quickly go to it and show you again. So let's go to, let's quickly go to the UI that's deployed currently. Just a second. So this is the UI that I was just showing, and to get this UI, you might think you need to do all kind of sophisticated stuff, but let's go back to the code. And what you see is that I currently have a container, and what that container does, it just adds the background and uses the full width of the screen. And to add the UI itself, I am just using the authenticator component. And the authenticator component comes from Amplify UI React library. So just by adding this and having the wrapper of the authenticator provider will allow us to access the configuration, and from there we will be able to log in, and it will know the user pool that is referencing that is referenced in the config here. So that's all you need to do. Later in the next episode, we will create a full custom login UI. But for now, this is a really easy and quick way to add authentication to your website. And with this, users can log in and sign up just like the UI from the hosted UI. But this time you have it on your website. So this is the really easiest way to get it in. So once you have it in, you might have noticed this function as well. So what I'm doing is, once you are logged in, I am using a use effect, and the use effect will check if the auth status is authenticated, and if the auth status is not authenticated, I will push the, sorry, I'm saying the incorrect. If it is authenticated, I will push the person to their account. And if someone is not authenticated, I will push them to login. So once they are in login and they authenticate and their authentication status changed from unauth to authenticated, they will go to the account. I will quickly demonstrate that here. So here we are not authenticated, we're on the login page. Then we sign in and we get redirected to login. And from login, once we have the auth user, we get redirected to the account page. So that's what happened here. Once we sign out, we're not authenticated on the account page, and we get redirected back to the login page. So let's go back to the code. So once again, use authenticator is from the UI pack, and in the authenticator you have the out status, you have the route, which you can also use to check if you are authenticated or not. You have the user, and the user also has some, I don't know why I'm using it here, honestly, maybe I should remove it, but the user has also user attributes that you can retrieve. And if you were wondering, there's also sign out. So with this, you can also sign out. So you have your auth status, you have your user, and you have your sign out. And now let's go to the account screen just to see how are we retrieving these account attributes, and how are we changing them, and how can you use it. So let's go to the account page. So in the account page, as you saw, once we are logged out, we are no longer authenticated, and we are getting pushed back to login. And we, oh wait, I do need to share my screen, 1 second. Okay, so we're in the account screen here, and as we saw before, after we are logged out, we are no longer authenticated, so the auth status gets changed, and we are again pushed back to login. So that's what happened after we logged out. We get pushed back to login just to log in, and you don't have to log in, but that is what we do. Then how are we retrieving all the attributes? And that would be this function here. So let's go through what is happening here, and then we can go through how to change it as well. So this is the fetching of the attributes, and fetching of the attributes, I'm creating an async function here, and if we are authenticated and I cannot find a name in the user state, I will fetch the attributes, and when fetching the attributes, I am using the user from the use authenticator from the React UI, and that user, I will get the get signed in user session, then get the ID token and the payload, and the payload should contain the user attributes. So if there is an object in the user attributes, I am getting the given name, the family name, the email, the phone number, and the address, and then I'm just storing them into state. And what's a big difference is that family name, email, these are all default attributes. You can just get them from the user attributes object, but the custom attributes, they are prefixed with custom. So maybe it's a bit small to see. Let's see if I can. this a bit better to see, but to get custom attributes, you have to append them with custom. So the business account in my case is a custom attribute, company name is a custom attribute, VAT number is a custom attribute, and newsletter is also a custom attribute, and these are all prefixed with custom. So this is how to retrieve them, and address in my case is just a string, and I am splitting it based on these lines. So it's just one string that I'm splitting into all these values, and that's pretty much how to retrieve the attributes. So once again, we're using the use authenticator, which is a React hook pretty much, and you have to use client when you're using use authenticator, and in it we have the user, and for the user attributes we are doing user dot get signed in user session, and then get ID token and the payload. And there's another way to do this as well, but to get all of the attributes, I saw that this was the easiest way to get the custom ones and the normal ones in one time. And finally, let's look at how to change these attributes once we have them, because we did add the admin scope. So now all users should also be able to change their given name, family name, email, and whatnot. So for that, let's go to account card and quickly here. Yeah. Okay. So in my case, when you open a dialog, as you could see, you can open the name and you can press save. And once you press save, I am executing this function, update user attribute. And what is the input here? You need to input the value name as it is in Cognito. So it is in this case email, and then I will add email and then dot close. So this function update user attribute is also in this case from utils. So let's go there and see what this function actually does. And this is how we are actually changing all the attributes. So we are getting the user from out.current authenticated user, and then I say bypass cache is true. What this means is that each time this function gets called, instead of looking inside of our cache if we still have the same user, we will each time get retrieve the user again, so refresh it, to say it easily. Then we are updating the attribute, so we need to pass in the user object and then the attributes we want to change. So I'm also logging the results and then catching the error, but this function is used to change all the attributes. I do need to say that for the password, this is not working, and for the phone number and for the email, you also need to confirm them, so that's also a different way of doing it. But for the name and the other custom attributes, this should work. Just to quickly show how the custom attribute is changed, is again prefixed with custom, and then the the name of the attribute that you want to change. So if you're using custom attributes, let's say you also want to add a newsletter or anything like that, you need to prefix it with custom and then a value. So how does that look? Again, you're getting auth from AWS Amplify, and then you're awaiting the current authenticated user, and then we will use this user to get the to update the user attributes for this user, and the attributes I'm getting here is an object of keys and values, which are both strings in this case. So that is how you also change the attributes. So what we've done now is imported the Cognito user, we can import their user attributes. We can also change their user attributes. Then the final thing left is to have a look at how to integrate the GraphQL API. So the final step that we need to do is integrate our GraphQL API queries into our Amplify stack. And if you've executed the commands that we ran through, you should by now have a folder called GraphQL with schema in it. And you should also have a file called API. And besides that, you should have another folder called GraphQL. And inside that folder, you should have your mutations and queries. And if you also have subscriptions, you should also have your subscriptions. And what this allows us to do is to create the GraphQL queries that we want. So in my case, as I said, I'm going to create the Stripe payment intender, and do that once the payment page has been loaded. I want to check if my shopping cart contains any items, and if it does contain any items, I want to send the cart to my backend. In this case, it will be a Lambda, of course. Lambda will receive the cart, it will validate all the products, and then it will return a price. Well, we will not return a price, but it will return the secret key for a payment intender. That's how Stripe works, which will have a price in it. So after receiving the secret key, I will display a payment intender that will allow a person to pay on my website. So let's have a look at the function itself. And another thing is, maybe you don't see that I'm using states because I'm using Valtio. So if you're unfamiliar with that, I'm using here Valtio, and Valtio is just a way to manage state globally, so I don't need to do it in each file if I'm using it in multiple places. But these are kind of my states. So let's have a look in the use effect and what are we doing to create an API call. So like I said, first I will check my cart if it has any items, and if it has any item, I will perform the function get payment intent. And what are we doing there? So again, get payment intent is an async function where we will await the API, and API is again coming from Amplify, and Amplify allows us to use this in this order. So we can just use API, and it will know that we are referring to the API that is in our AWS config. So the AWS export.js will be used to reference which API we are using. Then it's a GraphQL API, and here GraphQL query is also from AWS Amplify/API. So it indicates that we are doing a query, and which query we are doing is the payment intent query. And you should have your own query here. And where do we get this from? So in the API file, you should have all your queries and mutations and all these things. Just indicates which one we are expecting. Then the GraphQL operation is a function from Amplify to make it easy for you to create a GraphQL query operation. And what are we putting into that again? So this again is a value that you should get and might differ from me. It's the query itself, and that should also be generated. So after you have run the commands from Appsync, you should have this folder with queries, and so mine is payment intent, but yours could be different name. So don't search for payment intent if you have different queries and mutations. And in our query, we could see earlier in GraphQL that a payment intent has an input, and that input is an order. Order was an object that contained products, and products is in this case an array with products. So once the payment page gets hit, the use effect will be executed, and also when the cart changes. So for example, you add another product or you get the product out, that means that the price will change. So then the function, we want to run the function again and get a new price. And once we get the return of this value, so results, we will check if there's any data in the results. And if there's a data object, we are expecting that the payment intent should be in the string value that we are returning. And because I was also returning a status code, I am first parsing it and then getting out the client secret. And the client secret, if you're using just an object, just know that the results.data will contain your result object, but I am using the secret string, and that will be entered. Once we have it, it will be entered into the Stripe form, and Stripe will create the payment. So that's a quick and easy way, again, to add your GraphQL query to your AWS Amplify stack. And you can also add more ways to call an API. You can add the API to a button. So just know that this is just a really easy way to use your API, your GraphQL API, in the front end. And if you want to know more about that, you can always go to the documentation that we have. And let's say here, so there is a difference between fetching data and creating updates, but they have amazing examples. So if you do run into some trouble, have a look at the documentation, and that should help you a lot. So that will be all for this episode. In the next episode, we will focus a bit on getting the GraphQL API to work also for the payment intender with unauthenticated users. Because if we have a quick look at the website, we can actually get the payment intender now when we are logged in. But if we are not logged in, so let's have a quick look. So we are not logged in, then let's add this and proceed to payment. And what I'm expecting now is that we will not get anything. What's happening now is that because we added the GraphQL API, and it says that you have to be logged in with either GraphQL or IAM user, and currently we are neither of them, we are not getting the payment intender back. Then if we decide to sign in, quick sign in, okay, and we add again something to our cart, and currently we are logged in. And if you add Appsync GraphQL settings, as we did with standard authorization type at Cognito, that means that when you are logged in, it will automatically add the user's authentication ID to the request. So if I try to get the payment intender now, what I'm expecting is that I will get the payment intender. So, and as you see, currently we did get the payment intender, and the difference is that we now are signed in. So when we are sending the request, my identity gets attached to this API call, and I am able to get the secret key back. So in later videos, we will also enable this, that an unauthenticated user can get this request by getting the credentials with unauthenticated IAM user. We will also have a look at storing images into S3 bucket, and that will also contain authenticated users and unauthenticated users. And of course, we'll have a look at step functions. If you have any questions, then you can always add them in the comments. But if you made it this far, thank you for watching, of course. And please, if you're not subscribed, then consider to like and subscribe. It helps me a lot. But thank you all for watching, and Have a nice one. Until the next time.